Total eclipses of the sun are among the most majestic and exciting spectacles that nature is able to offer us, and astronomy enthusiasts are often willing to make long journeys around the globe to reach the areas where the total eclipse of the sun is visible. But why is it necessary to move to enjoy the spectacle of a total solar eclipse? Why are total solar eclipses observable only from some places on Earth and not from the whole diurnal hemisphere? Let's try to understand it in this video. In general, an eclipse is the temporary darkening of a celestial body by another celestial body that intercepts all or part of the light coming from the first celestial body. From the Earth, we can admire two types of eclipses: eclipse of the moon and the eclipse of the sun. Moon eclipses occur when the Earth is interposed between the sun and the moon in the phase of full moon, so the eclipsed body is the moon. Sun eclipses, on the other hand, occur when the moon in the new moon phase intervenes between the sun and the Earth, so in this case the sun is the eclipsed body. If the plane of the lunar orbit around the Earth lay exactly on the plane of the Earth's orbit around the sun, or the plane of the ecliptic, there would be a solar eclipse at each new moon, and a moon eclipse in which it is the Earth to be between the sun and the moon at each full moon. So in a month, we could see two eclipses, one of the sun and one of the moon. But in reality, the plane of the lunar orbit is inclined by about 5 degrees with respect to the plane of ecliptic. So the Earth's orbit and the lunar one intersect in 2 points called nodes: an ascending node in which the moon begins to travel the portion of the orbit above the Earth's orbit, and a descending node in which the moon begins to travel the part of the orbit below the ecliptic. The line joining the descending and ascending nodes is known as the line of nodes. From what has been said, it follows that to have a solar or lunar eclipse, it is necessary that the sun, Earth, and moon are aligned on the line of the nodes. And furthermore, the moon must be in correspondence with one of the two nodes. More closer the moon to the nodes, more the eclipse that will be observed will be total. That is, the eclipse star will be located for a longer time inside the shadow cone projected by the eclipsing body, and therefore the greater the coverage of the eclipsed body. In the case of a sun eclipse, the eclipsed body is precisely the sun, and the eclipsing body is the moon. If the moon, on the other hand, is not perfectly in correspondence with one of the nodes, then a partial eclipse will occur. But why can we observe this spectacular astronomical phenomenon from Earth? Because the moon and the sun have the same apparent diameter. That is, they subtend the same angle in the sky. To realize this, let's divide the diameter of the sun by its average distance from the Earth, and do the same thing for the moon. Sun diameter divided by Earth-Sun distance equals 1,392,000 kilometers, divided by 149,597,000 kilometers equals 0.009. Moon diameter divided by average Earth-Moon distance equals 3,478 kilometers, divided by 384,000 kilometers equals 0.009. As you can see, the values of the two ratios are the same. We can say the same thing in another way too. Sun diameter divided by moon diameter equals 1,392,000 kilometers, divided by 3,478 kilometers equals about 400. Distance Sun-Earth divided by distance Moon-Earth equals 149,597,000 kilometers, divided by 384,000 kilometers equals about 400. That is, that the sun is about 400 times larger than the moon, but 400 times farther than the moon. Or that the moon is 400 times smaller than the sun, but 400 times closer than the sun. While in the case of a total eclipse of the moon, our natural satellite is completely immersed in the shadow of the Earth, and therefore a total lunar eclipse is observable from the entire nocturnal hemisphere of our planet. For an eclipse of the sun, things are a bit different. Since the real diameter of the sun is much greater than that of the Earth and the moon, the shadow cone produced by the moon temporarily obscures only a narrow strip of the Earth's surface, about 200 to 250 kilometers thick, which is why a total solar eclipse is visible only from certain areas of the Earth. Due to the reciprocal motions of the Moon and the Earth's rotation, the belt of totality, that is, the part of the Earth's surface immersed in the shadow of the Moon, does not remain stationary, but moves along the Earth's surface. The width of the totality belt depends on how far the Sun and the Moon are during the eclipse. These distances vary because the orbits of the Earth and the Moon are not perfectly circular, but elliptical. In an elliptical orbit, there are two extreme points, one where the two celestial bodies are closest, and the other when the celestial bodies are most distant from each other. The shadow reaches its maximum width if an eclipse occurs when the Earth is in aphelion, the point of its orbit farthest from the Sun, and when the Moon is at the point of its orbit closest to the Earth, the perigee. Under these conditions, the Sun appears slightly smaller and the Moon slightly larger than average. In this way, the solar disk can be hidden from the lunar disk for longer. A large shadow slowly moving across the Earth produces a long total solar eclipse. The maximum possible duration of the totality phase is 7 minutes and 31 seconds and occurs when the following four conditions are verified simultaneously. Number 1. The observer is at the equator. Number 2. The totality phase occurs around noon. This is because the point on the Earth's surface where the maximum duration of the totality phase occurs must be close to the subsolar point. That is the area of the Earth closest to the Sun, and this happens precisely around noon. Number 3. The Earth is in aphelion. Number 4. The Moon is in perigee. The total solar eclipse of June 20th, 1955, the longest of the 20th century, was very close to these conditions, visible from the southern Chinese Sea. Its totality phase lasted a good 7 minutes and 7.7 seconds. The duration of the totality phase of the total solar eclipse of July 16, 2086, will be very close to the theoretical maximum, 7 minutes and 29 seconds. Instead, the shortest total eclipse of which we know is that of September 22, 1968, whose phase of totality lasted just 40 seconds. The extent of the phenomenon depends on the greater or lesser Earth-Sun and Earth-Moon distances. If the Moon is in the position of maximum proximity to the Earth, perigee, and at the same time the Earth is at the maximum distance from the Sun, aphelion, the shadow cone of the Moon is of maximum size and the solar disk appears in its apparent size minor, apparent because they depend on the distance. In these conditions, there is a total eclipse that affects restricted areas of the Earth's surface. In the surrounding areas where the penumbra disk is projected, there is a partial eclipse. In the opposite situation, Moon in apogee and Earth in perihelion, the shadow cone produced by the Moon is smaller and the size of the Sun's apparent disk is greater. In this case, the penumbral cone will be projected onto the Earth's surface, while the shadow cone will not touch the Earth's surface. We therefore speak of an annular solar eclipse. The duration of total eclipses is at most 7.5 minutes, while that of annular eclipses about 12. There is also a last type of solar eclipse, containing the combined effect of total eclipse in some places on the Earth and annular in others, speaking in this case of a hybrid eclipse. Each year they can occur from a minimum of 2 solar and 2 lunar eclipses to a maximum of 7, 5 of the Sun and 2 of the Moon, or 4 of the Sun and 3 of the Moon. It is possible to predict eclipses with a good approximation, taking into due account the fact that the line of nodes does not remain fixed, but completes a complete rotation in the plane of the Earth's orbit in 18 years, 11 days, and 8 hours. After this period, equal to 223 lunar months, the same positions occur between the Sun, Earth, and Moon. So the same sequence of eclipses will be repeated. It seems that this periodicity, which takes the name of Saros cycle, was known by the ancients. It includes 71 eclipses, of which 43 from the Sun and 28 from the Moon. 2 eclipses interspersed with the Saros cycle, however, will be visible in different regions of the Earth's surface, since Saros does not correspond to a whole number of days. In fact, the excess of 8 hours corresponds to a rotation of the Earth of about 120 degrees, and therefore the locations that will enjoy two eclipses separated by a Saros cycle will be spaced about 120 degrees in longitude. The total eclipse of the Sun has important scientific implications. First of all, the observation of the contacts between the edges of the disks of the Sun and the Moon, together with the determination of the limits of the shadow on the Earth's surface, allow the determination of the relative positions of the Sun, Moon, and Earth, allowing for a refinement of the theories concerning their movements. It is also possible to perform a verification of the theory of relativity. Moreover, during the totality phase, the crown and the protuberances are directly visible. The appearance of the corona, by now also observable outside eclipse by means of the chronograph, provides valuable information on the state of activity of the Sun. Furthermore, solar eclipses have played a very important role in Albert Einstein's theory of general relativity. According to Einstein's theory, a gravitational field is able to cause a light beam to deviate from its otherwise rectilinear trajectory, and more stronger the gravitational field, the more relevant this deflection. Since stars that are close to the Sun become visible during total eclipses, this consequence of the theory can be experimentally verified by photographing these stars when the Sun is eclipsed by the Moon and then photographing them again 6 months later, i.e. in the middle of the night, in order to evaluate the apparent displacement actually due to the deflection by the solar mass. The first measurement of the extent of this deflection of light was made thanks to the observation of the solar eclipse of May 29, 1919. As we said at the beginning, the observation of a total solar eclipse is really exciting, especially when the phase of totality is approaching, provided, however, that you use appropriate sunscreens applied to binoculars and telescopes to protect the eyes from intense sunlight during the partial phases of the solar eclipse, i.e. those before and after the totality phase. When the coverage of the solar disk is around 80 to 85%, a decrease in daylight begins to be observed, and the temperature also decreases. A slight eclipse wind also rises due to the variation in atmospheric pressure resulting from the decrease in brightness. The remaining sunlight that pierces through the holes of the wearer of straw hats produces luminous flecks in the shape of a crescent, a sign that now totality is near. During the totality, it is interesting to observe the behavior of animals. For example, the hens go to sleep, while dogs and horses understand that something unusual is happening, and they react by barking and neighing. The bewildered birds return to their nests preparing for an unexpected night, and so do the flowers that, mocked by nature, close their petals. About a minute before the totality and until the establishment of the same, it can happen to observe the flying shadows a few centimeters wide. This phenomenon occurs again for an equal interval of time, even at the end of totality. They are probably the result of continuous fluctuations in the refractive index of the Earth's atmosphere. This is a phenomenon of which there is no great documentation, as it is difficult to photograph due to the rapid movement and low contrast, about 1%, between the light and dark stripes. During the totality phase, the solar corona, the outer gas envelope of our star, shows itself in all its splendor. Many people rejoice. The impression is of being in a kind of twilight, as if the Sun was rising at 360 degrees instead of only on one side. In conclusion, the observation of a total solar eclipse should be experienced at least once. Thanks for watching, everyone. See you next time on the channel.